Good evening, students. I am going to start the class. Okay. Previously, we discussed about the atmospheric refraction, and its continuation I am going to explain now. Now, what is atmospheric refraction? What is the definition of atmospheric refraction? And little information before going to know about the atmospheric refraction and its applications. I will give some information that you know very well. What is actually refraction? What is refraction? Refraction means, is it clear, students? Is the board is appearing? Whether my voice is clear or not? Write in the chat box if you have any problem. I'm going to write the atmospheric refraction and its application. What is atmospheric refraction and what is a refraction? When the light moves from one medium to another medium, it bends at the separation of two mediums. That bending phenomena is called as atmospheric refraction. What is atmospheric refraction? Atmospheric refraction is the refraction of light, refraction of light, bending of light at the separation of two mediums. I will give some applications for this. Let us consider this is a swimming pool. It is a swimming pool. And now one fellow is at the outside of the swimming pool and he is observing the bottom of the swimming pool. When he observed the bottom of the swimming pool, from the bottom one light ray will comes. From the bottom one light ray will comes. This light ray is trying to move from water to water to air. That means it is going from rarer medium to denser medium. And now it is the normal drawn. We will draw the normal at here. This is the normal drawn. When light ray moves from rarer medium to denser medium, or it will bend towards the normal. But in this case, the light ray is moving from denser to rarer. Well, it will bend away from the normal. When it will bend away from the normal, it cannot go in the straight like this because the medium is changing. If there is no change in the medium, then the light can travel in the straight line like this. But what happening due to the change in the medium, light ray will bends. It is bending like this. How it is bends? It bends away from the normal. This is the normal. From the normal away it will bends. This side it will bends. And this is the reaching the person's eye. Right? The light is reaching the person's eye now. Now when we do this light extension, okay, it will goes back like this. When we will do the extension of this light ray, then it is going this side. That's why what happens, the bed will not appear at here, it will appear at here. Then what he feels that the depth of the, actually the light ray is coming from the bed of the, light ray is coming from the bed of the swimming pool. Okay, from the bottom of the swimming pool. But what happening due to the bending of the light ray? Light ray is bending like this after entering into the other medium. When the light ray moves from water to air, it is bending. Due to the bending, okay, this bed, original bed will not appear. This will be bed is little shifted in upward direction. Then when the fellow which who is from outside, if he sees, then he feels that the depth of the swimming pool is less, but real depth is this one. Really this much depth is there, but due to the light it appears at less depth. Okay, Then he feels that the depth of the uh, swimming pool is less, but in reality it is more. This is happens due to the refraction. Have you understood this concept? Why it is happening? Because of the bending. For example, something I will also explain like this. For example, here one object is there. He is observing one object at here like this. Okay, and the light ray started from the object. Light ray started from the object, and when the light ray moves from other medium, it will bends like this. It will bends. Okay, when any person, if he sees this object, okay, this blue color object, okay, from outside, and then at the moment what happens, light never goes in the straight, it is bending like this, and then you can do the extension at here. Then at the moment this object appears at here. That means what happens, the object never appears at here, it appears at here. That means, for example, simply I will explain. For example, this is here, there is one object is there. From the object, light ray straightly comes to you and reaches your eye. Then you can see that object. But the same like this, it is there. This is an object. But due to some reason, the light is bending, 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 and reaching the eye like this. Right? In this case, the light is came straight. Then the object appears at original location. But when the light ray is bends due to any reason and it reaches the eye, it is bending, it is not going in the straight. Why it is bending? Because of change in medium, let us consider. And it is also reaches the eye. At the moment, this original object cannot seen by this person. This object position is shifted to somewhere. You do the extension of this light ray, right? You do the extension for this light ray. Then, like this, you have to do the extension. Then it appears it here. That means this original one not appears, this one appears. Okay, like this. This is the uh, this is happens due to the light. You have to extend the light ray in the straight. Okay, in the straight when you will extend, then at this location instead of original object, its image appears at some other location. Okay, original object not appears, and he feels that the object is at long distance. Firstly, originally the object is at h height, but the fellow feels that the object is at h dash height. This will happen due to the light. Okay, and this is also due to the refraction. For example, you keep one pen at here. Then for you, when you will observe from outside, this pen appears like this. It is broken like this. It is bends. It appears. Why it is appearing? Real pen is like this there, but apparent will appears like this. What is the reason for this? This is also refraction. These are some applications of the refraction. Okay, right. And now we are discussing the atmospheric refraction. I am explaining the atmospheric refraction. You listen very carefully. I am going to erase. Actual topic I am going to start. Atmospheric refraction. Atmospheric refraction means that is the refraction of light by the atmosphere. Okay. And what are the applications of this one? And definition of this atmospheric refraction is what? Refraction of light by the different layers of atmosphere. Refraction of light by the different layers of atmosphere is called as refraction. Actually, atmosphere consists air. If air different media, air different layers. If air is split into different layers, if different layers will act as different mediums, then that is atmospheric refraction. When light atmosphere act as different layers of atmosphere act as different mediums. When light passes through the different mediums, then what happens? It will bend. Like that, when the light passes through the atmosphere, also it will bend. The bending of light while passing through the different layers of atmosphere is called as the refraction. Okay, atmospheric refraction. Refraction of light by the different layers of atmosphere. Okay, and now its applications are there. There are two applications. In that one, we already discussed. Okay, what is that one? First one is that important application, that is a twinkling of stars. Right, this we discussed. Twinkling of stars, and apparent position of the star is a little bit higher than the actual position. And the second application is advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset. Delayed sunset. These are the two applications. This is occurs due to our Earth atmosphere. If Earth not have the atmosphere, then stars cannot twinkle. Okay, and advanced sunrise, delayed sunset also not appears. This is occurs due to the atmospheric refraction. I will explain little bit. I will revise it within 1 minute. The twinkling of stars. Only within 1 minute I will revise. Twinkling of stars is what? Star is at very far distance from our Earth, right? For example, this is the our star. Okay, this is our star, and this is the Earth, and the star is at very large height from the atmosphere, large height from the ground. Okay, this is the ground, and now starlight starts at here. Star is appears just like pint size. The starlight passes through the different layers of atmosphere. When the starlight passes through the different layers of atmosphere, it will bends towards the normal and finally reaches the person. Okay, right. This fellow is observing that one, and now you do the extension of this light ray. This light ray is bending. Okay, and when you will split this atmosphere into different layers. Okay, this high density layer is at the bottom, high density layer at the bottom, low density layer at the top. This is denser, upper layer dense rarer, lower layer denser. High density, when you compare these two, the lower layer has more density, it is denser. Upper layer less density, rarer. Okay, when light ray moves from rarer to denser medium, what happens? Every time light ray is moving through the different layers of atmosphere, at the moment every time light ray is moving from rarer to denser medium, due to that it will bend towards the normal. You know already, when light ray moves from rarer to denser, it will bend towards the normal. When light ray moves from denser to rarer, it will bend away from the normal. Okay, this is the normal. Actual path is this one. It cannot go in the straight. It will bend away from the normal. And when light ray moves from denser to rarer, you see here the light ray is moving from denser to rarer. It cannot go in the straight because medium changing. It is bends. Whether this side it will bend or this side it will bend. It will bend this side. Why? Because it is moving from denser to rarer. If the light ray moves from rarer to denser, you see this light ray is moving from rarer to denser. At the moment its medium is changing. It cannot go in the straight. This is the normal drawn for the surface, normal. Now it will bend towards the normal, it will go like this, right? That means when the light ray moves from rarer to denser, it will goes from, it will bend, when light ray moves from rarer to denser, it will bends, tell me, when light ray moves from rarer to denser medium, it will bends towards the normal. When light ray moves from denser to rarer medium, it will bends away from the normal, right? Okay, now I will continue. You listen very carefully. And what I am doing it here, you do the extension for this light ray. You do the extension for this light ray. If we do the extension for this light ray, this light ray is coming like this. Here what happening? Light ray is moving from where to where? The light ray is always moving from rarer to denser medium through the atmosphere. Light is coming from the star. This is actual position of the star, and you do the extension at here for the starlight. When we will do the extension, then the star is appears at here. Okay, this is the apparent position of the star. This is actual position. Okay, this is apparent position of the star. That means from the when any person sees from the earth surface, okay, somebody is seeing the star from the earth. At the moment, the star apparent position, star appears little bit above than actual position. Actually स्टार इधर है, बट आपको इधर दिखाता है, थोड़ा ऊपर में दिखाता है। ये वाला क्यों हुआ? रिफ्रैक्शन का वजह से। लाइट रे स्टार लाइट से आ रहा, स्टार से आ रहा है, वैसे वैसे आने के समय में हर बार लाइट रे बेंड हो रहा है, बिकॉज लाइट रे अलग अलग मीडियम से जा रहा है। पूरा एटमॉस्फेयर है, बट डिफरेंट लेयर्स डिफरेंट मीडियम से रिएक्ट करता है। इसका वजह से लाइट रे नॉर्मल साइड बेंड होगा। ऐसे बेंड होने के बाद उसको पीछे एक्सटेंशन करते तो ये लाइट इधर से आ रहा है वैसे दिखाता है, लाइट किधर से आ रहा है दिखाता है उधर से। इधर से नहीं आता है, लाइट स्ट्रेट स्ट्रेट में जाता है ना। ओरिजिनली इधर से आ रहा है, बट स्ट्रेटली एक्सटेंशन करते तो इधर जा रहा है। मतलब लाइट इधर से आ रहा है वैसे दिखाता है, इधर स्टार अपीयर होता है। राइट, तो मीन्स ओरिजिनल स्टार नहीं दिखाएगा, उसका इमेज थोड़ा ऊपर में आपको दिखाएगा। स्टार लिटिल बिट अपीयर्स लिटिल बिट अबव द ओरिजिनल पोजीशन। ओके, now they will ask the question, previous 5 marks question this one. Explain the twinkling of stars and why the apparent position of the star is higher than the actual position. Apparent position is higher than the actual position, right? It is one word reason is atmospheric refraction. Why we have to explain? Okay, I explain it now. I am not giving the notes. Just come little bit. You read the textbook. And the next one is, okay, this is apparent position is higher than the actual position. Okay, apparent position of star is higher than the actual position. Apparent position is little bit higher than apparent position is apparent position of star is above the apparent position of star is above the actual position. Okay, right, little height में दिखाता है। Right. Next, I will give one point. Why stars twinkle? Twinkle means what? Sometimes light appears with star appears with more brightness. Sometimes star appears with less brightness. Reason is that the star is at point size. From the point size, one light ray will start. This light ray sometimes due to the bending, it is reaching the eye. For example, atmosphere is changing every time. Atmosphere densities are changes. Okay, that's why sometime light will bend and it goes in different way. It cannot reach the eye. When sometime more amount of light reaches the eye, sometime light goes to other direction because of change in the atmosphere. That's where always fluctuation is occurred in the atmosphere due to the starlight. This is the star. Starlight sometimes reaches the eye, sometimes not reaches the eye. When the starlight reaches the eye, it appears bright. When starlight not reaches the eye, then it not appears as bright, it will appear dark. Like this, due to the change in the amount of light reaching the eye, the star appears twinkling. Okay, this is the reason. And why planets not appears twinkle? Okay, star is twinkling but the planets not twinkles. Okay, the reason is that we cannot say that the planet has it does not have the its own light. Stars have their own light, okay, no problem, but the planets not have the own light. Even though sunlight falls on the planets and it will be reflects. Okay, just like moon. Okay, moon cannot twinkle, is it right? Moon is also natural planet. Okay, natural satellite for the Earth. Okay, why it cannot twinkle? Because when you compare the planet, stars and planets, the planets are nearer to the Earth. Then it can take as many point sources. From every point source, light rays will emit. One light ray, if it is not reaches, other light ray may reaches the eye. Right? Like that, what happens? The variation of light due to one point source. Okay, you have to divide the planet into different parts and the variation due to one part is nullified with the other part. एक पार्ट से आपको वेरिएशन दिखाएगा बट उस पार्ट को दूसरा पार्ट से लाइट आ रहा है या वाला आंख को रीच होगा, इसका वजह से आपको पूरा ट्विंकलिंग नहीं दिखाता है। ट्विंकलिंग दिखाने के लिए नहीं दिखाने के लिए रीजन क्या होता है? प्लैनेट अर्थ का आसपास में होता है। प्लैनेट को हम लोग मिनी पॉइंट साइज ऑब्जेक्ट तरीका दे सकते हैं, मिनी स्टार्स तरीका ले सकता है। कुछ पॉइंट्स से लाइट आ रहा है, कुछ पॉइंट से नहीं आते, तो ये दोनों बैलेंस हो जाएगा, नलिफाई हो जाएगा, वेरिएशन ऑफ द लाइट कैंसिल हो जाएगा। वेरिएशन ऑफ द लाइट मीन्स एक बार ज्यादा लाइट आता है, आंख को रीच होता है, एक बार कम लाइट आंख को रीच होता है। वैसे आंख को रीच होने वाला लाइट चेंज होते तो आपको एक बार ब्राइट दिखाता है, एक बार फेंट दिखाता है, लेस 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 ब्राइटनेस में दिखाता है। दिस इज द रीजन फॉर द ट्विंकलिंग ऑफ स्टार्स। स्टार्स twinkle but the planets cannot twinkle. Okay, planets not twinkle. Okay, because planet is the big size. Why it is big size? Star also big size, but the planets are close, that's why they appear as big size, and the stars are very far distance from the earth, that's why they will appear as planet size. Planets are close, that's why they will appear as big. Okay, right. Is it clear till now, students? No. Is it clear or not? Any problem? Students? Is it clear till now, students? Write in the chat box. Next topic is one more application of the one more application of twinkling of stars. What is that? Advanced sunrise and delayed sunset. Okay, right. This I am going to explain. This topic I am not explained in the previous. Right. What is that? Advanced sunrise and delayed sunset. Okay, I will erase this total. Or no need. Advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset. What is this? Advanced sunrise means what? Delayed sunset is what? I will explain. It was very interesting. You listen very carefully. Okay. And this is the earth. This is the earth. This is the earth atmosphere. Okay. Uh, this is the earth. And what is this? This is the atmosphere. Okay. This is atmosphere. And now one fellow is standing at here. Okay. He is observing this sun. If the sun will comes above the horizontal, right? You see here. This is the horizontal. This line is said to be horizontal. Okay, horizontal means you know that one, x-axis, just like x-axis. If the star moves above the horizontal, if the star is above the horizontal, we say that the sunrise occurs. If the star moves below the horizontal, okay, below the horizontal, when the star moves below the horizontal, then we say that sunset occurs. Okay, for example, this is north, south, east, west. Okay, in the east, sunrise will occur. In the west, sunset will occur. If the sun appears above the horizontal, you see, generally you will see the sun like this. This is your eye. You will see like this in the morning, and it will rises like this. In the afternoon, it will come at the top of your head, right? And the sun will. This is the sun location in the afternoon. In the evening, it will comes like this. It will rotate like this. It appears in the morning here, in the afternoon here, in the night here, in the evening at here. Now, actually, the sun is at here. Let us consider this is the original location of the sun. Okay, and the sun is below the horizontal now. Okay, generally we say that there is no, now the sun not appears generally as per rule, but sun should not appear. But what happens? This sunlight, it passes through the several layers of different layers of You see here, the sunlight started at here. It is going in straight. It is going in straight. But after entering into the atmosphere, it will bends. It will bends, and reaches the eye. At the moment, what happens? Okay, it will reaches the eye at here like this. It is bending and bending. It reaches the person's eye. When we will do the extension of this light ray, okay, when we will do the extension of the light ray, then the star appears at here. What happening at here? This is actual position of the star, actual position. But the actual position of the sun is this one. Sun actual position this one. But apparent position is this one. That means when sun is below the horizontal, okay, due to the refraction, light is coming from here. It is when it passes through the different layers of atmosphere, it will bends, and due to the bending, the light sun is appearing above the horizontal. In the reality, sun is below the horizontal. In the reality, okay, really the sun is below the horizontal, but due to the bending phenomena, sun appears, okay, sun appears above the horizontal. You see here, have you understood this one? Actually, the sunlight starts at here like this. And this is the original position of the sun. Sunlight starts at here and goes like this. When it enters into the atmosphere, different layers will act as different mediums. Then it will bend towards the normal, bends, and reaches the person's eye. And due to you can do the extension for this, and then sun appears it here, because लाइट सीधा कहाँ से आ रहा है, ऐसे अपियर होता है. लाइट एक्चुअली सीधा आता है ना, राइट. कहाँ से आ रहा है, सीधा लाइट को एक्सटेंशन करिए, इधर आने वाला आंख को रीच होने वाला लाइट रे को पीछे एक्सटेंशन करते तो कहा जाएगा, वह आपको सन दिखाएगा. ओरिजिनली लाइट रेस नीचे से आ रहा है, बट इधर आने के बेंडिंग का वजह से लाइट रे ऐसे रीच हो गया आंख को, उसको पीछे एक्सटेंशन करते तो ऐसे आ गया, राइट. मतलब ओरिजिनली सन हॉरिजॉन्टल का नीचे है. ओरिजिनली सन इज एट हियर बिलो द हॉरिजॉन्टल. सन इज बिलो द हॉरिजॉन्टल. ओरिजिनली सन इज बिलो द हॉरिजॉन्टल. दिस इज हॉरिजॉन्टल, राइट. बट क्या हो रहा है, लाइट का वजह से सन अबव हॉरिजॉन्टल दिखा रहा है, अपियर होगा. मतलब क्या हो जाएगा, आप क्या फील होगा, ये फील क्या फील हो जाएगा, ये वाला फील हो जाएगा दैट सनराइज हो गया. बट एक्चुअली सन बिलो हॉरिजॉन्टल है, सनराइज नहीं हुआ, बट सन अबव हॉरिजॉन्टल दिखा रहा है. उसका वजह से ये पर्सन क्या फील हो जाएगा, राइट. सनसेट सनराइज हो गया ऐसे फील हो जाएगा. मतलब कितना मिनट पहले ऐसे दिखाएगा, कितना मिनट पहले ऐसे दिखाएगा, राइट. देन 2 मिनट बिफोर द सनराइज. मतलब एक्चुअली सन हॉरिजॉन्टल इधर है और आता है. देन 2 मिनट के बाद सन एक्चुअली सनराइज होता है, उसका पहले आपको दिखाता है सन ऊपर में. मतलब सन अपियर्स 2 मिनट बिफोर एक्चुअल सनराइज. ओके, सन अपियर्स sun appears 2 minutes before actual sunrise. 2 मिनट पहले सन दिखाता है आपको. क्या, किसका वजह से? सन बिलो हॉरिजॉन्टल है, लाइट रिफ्रैक्शन का वजह से वो हॉरिजॉन्टल दिखा रहा है. वो हॉरिजॉन्टल दिखा रहा है मतलब आप फील हो जाएगा सनराइज हो गया, सनराइज हो गया, राइट. नाउ अभी सनसेट का वजह से बताएंगे, सनसेट का बारे में बताएंगे. सनसेट क्या होता है, सन नीचे आ गया, हॉरिजॉन्टल के नीचे आ गया सन. अभी देखिए, समझने के लिए ट्राई करिए, कोशिश करिए, समझिएगा, टाइम लगेगा, राइट. समझिए, समझने के लिए कोशिश करिए. सन इधर है, मतलब सन हॉरिजॉन्टल के नीचे आ गया, ओके. सन इधर होते तो आपको सनसेट हो रहा है वैसे होता है, राइट. सन नीचे आ गया, अभी सन नीचे आ गया, मतलब आपको ये वाला नहीं दिखाना होगा, बट क्या होगा, सनसेट हो गया एक्चुअली, रियल सन इज इट हियर. सनसेट हो गया, सन हॉरिजॉन्टल के नीचे आ गया, ओके, हॉरिजॉन्टल मतलब ये लाइन है, ये लाइन के नीचे आ गए मतलब सन नहीं दिखाना होगा आपको। ओके, आप देखिए हॉरिजॉन्टली। ओके, राइट, ये वाला हॉरिजॉन्टल है, हॉरिजॉन्टली दिखते तो सन दिखाते तो सनसेट नहीं हुआ, सन नहीं दिखाते तो सनसेट हो गया। बट एक्चुअली सन इधर है, बट सन नहीं दिखाना होगा। बट लाइट रेस, फॉर एग्जांपल लाइट रेस स्टार्ट हो गया इधर से, लाइट रेस इधर से स्टार्ट हो गया, ऐसे 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 जा रहा है, एटमॉस्फेयर में एंटर करने के बाद बेंड हो जाएगा, बेंड होके ऐसे आंख को रीच हो जाएगा, उसको पीछे एक्सटेंशन करिए स्ट्रेट लाइन में, मतलब सन इधर दिखाएगा आपको। व्हाट हैपनिंग इट हियर, दिस इज अपर एंड पोजीशन ऑफ सन, अपर एंड पोजीशन ऑफ सन, दैट मीन सन ऑलरेडी ऑरिएंटल के नीचे चला गया, सन ऑलरेडी चला गया, सन शुड नॉट अपीयर, बट लाइट का रिफ्रैक्शन का वजह से सन एबो हॉरिजॉन्टल दिखा रहा है। और थोड़ा नीचे जाते तो फिर आपको और नीचे जाएगा ये वाला, उस समय में आपको सनसेट हो जाएगा। मतलब सनसेट रियली सनसेट हो गया, बट फिर भी आपको सन इधर दिखाता है, सन ऑलरेडी नीचे हॉरिजॉन्टल के नीचे चला गया, फिर भी सन इधर दिखाता है, राइट। दैट मीन्स सनसेट के बाद भी आपको थोड़ा समय सन को देखता है, रियल सनसेट के बाद भी आपको आप सनसेट सन को देखता है, उसको डिलेड सनसेट बोलता है, सनसेट लेट हो जाएगा, मतलब अब सनसेट के बाद भी आप सन सन को देख रहा है, आप फील हो जाएगा, राइट, सनसेट नहीं हुआ ऐसे। दैट मीन्स सन अपियर्स, सन अपियर्स कितना मिनट्स सनसेट के बाद, सन हॉरिजॉन्टल से नीचे जाने के बाद भी कितना मिनट आपको दिखाएगा, सन अपियर्स 2 मिनट आफ्टर सनसेट आल्सो, 2 मिनट के बाद सनसेट हुआ, रियली सनसेट हुआ, बट फिर भी आपको सन सन दिखाएगा 2 मिनट एक्स्ट्रा, मतलब सन सनराइज नहीं हुआ, फिर भी आपको सन दिखाएगा, मतलब सन अर्लीली दिखाएगा, एंड सन डिसअपियर होने के बाद 2 मिनट लेट से भी दिखाएगा, मतलब पूरा लेंथ ऑफ द डे कितना एटमॉस्फेयर की वजह से ये वाला होता है, लेंथ ऑफ द डे कितना इंक्रीज होगा ड्यू टू एटमॉस्फेयर, ड्यू टू एटमॉस्फेयर। लेंथ ऑफ द डे अभी कितना है, 24 आवर्स है। एक्चुअली ये एटमॉस्फेयर वजह से लेंथ ऑफ द डे 4 मिनट इंक्रीज होता है, लेंथ ऑफ द डे, लेंथ ऑफ द डे मीन्स 24 आवर्स, ड्यू टू एटमॉस्फेयर, राइट, लेंथ ऑफ द डे इंक्रीजेस बाय 4 मिनट्स, इंक्रीजेस बाय 4 मिनट्स। आप एटमॉस्फेयर नहीं होते तो अभी हमारा लेंथ ऑफ द डे 24 आवर्स है ना, उसको 4 मिनट कम हो जाएगा, एटमॉस्फेयर नहीं होते तो, राइट, 4 मिनट कम हो जाएगा, राइट, दैट मींस लेंथ ऑफ द डे बिकम 23 आवर्स 56 मिनट्स ओनली। कब, कब होगा 23 आवर्स 56 मिनट्स, हमारा अर्थ में एटमॉस्फेयर नहीं होते तो, जस्ट अजम्पशन है, राइट। दिस इज एडवांस्ड सनराइज एंड डिलेड सनसेट। ओके, जितेश मातो क्या डाउट है आपका, नॉट क्लियर, क्या क्वेश्चन बताइए, कहा नॉट नॉट क्लियर। ये क्या है, सनसेट का पहले आपको सन दिखाता है, सनसेट के बाद भी आपको सन दिखाता है, कितना टाइम दिखाता है, 2 मिनट, खाली 2 मिनट। ओके, 2 मिनट दिखाता है, मतलब 2 मिनट सनसेट का पहले, 2 मिनट का पहले आपको, सॉरी, सनराइज का 2 मिनट का पहले, एक्चुअल सनराइज का 2 मिनट का पहले आपको सनराइज हो गया वैसे फील होता है, सन भी दिखाएगा ड्यू टू द लाइट, सनसेट के बाद, एक्चुअल सनसेट के बाद भी आपको सन दिखाएगा। Okay, this is about atmospheric refraction. Okay, any doubts regarding this topic? Kindly ask me. Otherwise, I will go to the next topic. Anyone can, you can ask anything. Okay, next. Next topic is also very important. Okay, the next topic is the scattering of light. Scattering of light. Have you have you heard the word scattering of light? What is scattering? Anyone can tell the what is scattering of light? Scattering of light is the deviation. Deviation means a change in, okay, deviation of light ray from its original path. Deviation means change in direction of motion of light. लाइट एक्चुअली सीधा जाता है, ये वाला उसका डायरेक्शन चेंज होता है, राइट. The deviation of light ray from its original path by the large number of large number of particles such as smoke, tiny water drops, water droplets. Tiny means small, okay, dust particles is called as scattering of light. Scattering of light is the deviation of the light ray. Okay, scattering of light. Deviation means change in the direction of light ray. For example, light ray is traveling like this, but due to the some particles at here, due to the particles at here, light ray is going like this. That means the light is the direction is changing. Direction of motion of light is changing. Change in direction of light due to the particles in the medium. Okay, due to the large number of particles such as smoke, tiny water droplets, dust particles is called as a scattering of light. Okay, for example, simply, for example, you one teacher is at here, one student is walking like this. Okay, and then he saw the teacher and he changed. He want to go straight actually, but due to the teacher, he saw the teacher, he changed the direction, and this is the scattering, right? And the path of the person is changed because of this teacher, right? Similarly, here the light ray is try to go in this direction, but due to the particles, its path is changing. Then that is called as scattering. Okay. Now next, what are the applications of scattering? Scattering the right? Do you know visible light? Visible light, white light has some. White light is the combination of some colors, right? White light is the combination of some colors. Do you know what are they? Anyone can tell? Visible light is the combination of some colors. What are they? Yes, it is the WIBGR. You remember it. It is the code. White light is the combination of seven colors. Okay, white light is the combination of seven colors. White light is the combination of seven colors. This is WIBGR. When we will go to right side, okay, when you will go to right side, the wavelength is increases. Wavelength is increases. Wavelength means what? Light travel in the form of wave, right? Now this is the first crest, this is the second crest. The distance between the successive crests is called as the wavelength. And different colors have the different wavelengths. White light is the combination of visible light is the white light. White light is the combination of seven colors, right? Violet, indigo, blue, green, yellow, orange, red. These are the seven colors. Then in that highest wavelength, okay, blue color has low wavelength comparing with the red color. Remember it. Okay, blue color has less wavelength comparing with the red color. Red color has the highest wavelength. Red color has among all color lights, red color has the highest wavelength. Okay, red color has highest wavelength. Okay, lowest wavelength is for what? Violet color. Okay, violet color has lowest wavelength in all the colors. Okay, right, this is about scattering of light. Then when we will see this, for example, scattering is occurred due to the particles in the medium, right? Due to the particles in the medium, scattering is occurred. Then what are the particles? For example, based on the size of the particles, okay, color of scattering of light, color of scattering of light, right? Color of scattering of light depends upon size of particles. Okay, color of scattering particles depends upon size of particles. Okay, let us see how what type of particles can scatter the which type of color. First point you remember, very fine particles. Very fine particles means a small particles. Okay, very fine particles means a small particles. Okay, scatter mainly blue color light. Okay, blue light, बहुत छोटा छोटा पार्टिकल्स ब्लू कलर को स्कैटर करता है ज्यादा। ओके, बहुत छोटा छोटा पार्टिकल्स होता है, वेरी फाइन मतलब बहुत छोटा पार्टिकल्स क्या करता है, ब्लू लाइट को स्कैटर करता है, ब्लू लाइट को बेंड करता है। ओके, राइट, ऐसा होता है। फॉर एग्जाम्पल कुछ टीचर्स को ऐसा होता है, बेस्ड ऑन द पार्टिकल होता है, राइट। फॉर एग्जाम्पल एक स्टूडेंट जा रहा है इधर, एक स्टूडेंट, एक टीचर है, एक टीचर होते तो ऐसे टीचर होने के बाद भी सीधा जाता है, राइट। मतलब एक टीचर है इधर, राइट, इधर टीचर होते तो थोड़ा थोड़ा बगल में ऐसे जाता है, राइट। एक टीचर के पास पूरा उसी को दिखाना नहीं, मतलब ऐसे सोच के then पूरा डायरेक्शन चेंज करता है, मतलब based on the teacher then the student behavior will be there. Similarly, what happening it here, based on the particle in the medium, based on the particle in the medium, size of the particle in the medium, eh, कुछ particles blue color को bend करेगा, कुछ particles white color को bend करेगा, कुछ particles some red color को bend करेगा। ऐसे होता है, कौन किसको बेंड करेगा ये वाला एक्सप्लेन कर रहा है मैंने। बहुत छोटा पार्टिकल्स ब्लू कलर को बेंड करता है। ओके, बहुत छोटा पार्टिकल्स ब्लू कलर को बेंड करता है। नेक्स्ट, second point I am going to give, that is a little bit large size particles you will take, large size particles. Okay, first one, small particles. Small particles scatter the blue light. The blue light is the lower wavelength na? Less wavelength, right? Less wavelength, blue light is the less wavelength. And large particles scatter, large particles scatter light of longer wavelength, light of longer wavelength। ओके, लॉन्गर वेवलेंथ मतलब क्या होता है, रेड कलर को स्कैटर करेगा, राइट। वेरी लार्ज साइज लीजिए, राइट, एनफ लार्ज साइज, एनफ लार्ज साइज मीन्स वेरी बिग साइज पार्टिकल, एनफ लार्ज साइज particles scatter white light, व्हाइट लाइट को बेंड करता है ऐसे। ओके, राइट, टेक द स्क्रीनशॉट एंड नोट इट, some important points I am giving. I am going to erase, I will continue for the more 10 minutes. Next topic is what are the applications of scattering of light? What are the applications of scattering of light? You see, due to the scattering, you can see the uh, due to the scattering, you can see the path of the light. Where you will see the scattering. Okay, and scattering some applications I will give. Before that, I will give one more definition. Tyndall effect means what? Tyndall effect. Tyndall effect means the scattering of light. It is also scattering of light only called as Tyndall effect. The scattering of light by the colloidal particles. Colloidal particles is called as Tyndall effect. What is Tyndall effect? Scattering of light by the colloidal particles. Colloidal means what? Suspended particles. Okay, suspended particles. Tyndall effect application I will say. For example, this is a home. Okay, for example, the home is filled with completely dust. Okay, for example, and there is a window at here. From the window, the light is entering. Okay, this light appears at here in, like this in the beam of light. This light is appeared because of we can see the path of the light here. We can see the path of the light rays are going like this. Okay, when the window goes, and even see we see the dust particles also, right? Like this, the path of the particle will become the visible due to these dust particles. This is called the Tyndall effect. That means light ray which will bends from the original path and it can reaches your eye. Due to that, you can see that one. And I will explain some applications of the scattering. Okay, applications of scattering. Colloidal particles means what? Colloidal means suspended particles. Applications of scattering. You understood very well. If you will explain these applications. Applications of scattering. Okay, let us start. The first application is just I will give the names today and tomorrow I will continue. That is sky appears blue color, right? Sky appears blue color from earth. That is due to scattering. Sun appears red during sunset and sunrise. That is also ड्यू टू स्कैटरिंग. अगर स्कैटरिंग की वजह से आपको स्काई ब्लू कलर में दिखाता है और सनसेट सनराइज का समय में सन रेड कलर में दिखाता है. रिमेनिंग हम लोग नेक्स्ट क्लास में टुमारो डिस्कस करेंगे. लास्ट टॉपिक बचा हुआ आप लोग को सिलेबस खत्म हो जाएगा कल. कल से कल एक टॉपिक बताते तो पूरा 10th क्लास का सिलेबस खत्म हो जाएगा. ओके, राइट. एक चैप्टर और एक है बट ये वाला डिलीट किया हुआ. అయిపోయింది. చైనా